So now we will switch over to discrete outputs. Devices wired to discrete outputs like indicator lights, solenoids, or relay coils are load devices. These load devices, when connected properly to PLC outputs, form electric circuits. It is the PLC outputs that do the switching in the circuit for each load device. Generally, there are three types of hardware doing the switching. That would be transistors, triacs, and relay contacts. A transistor is a semiconductor device for switching DC. A triac is a semiconductor device that switches AC. Relay contacts can handle both AC and DC, as well as higher currents, but relays have a mechanical reaction time, so they are slower than semiconductors. Based on our previous statement for discrete outputs, we know if the PLC memory for the assigned output is set to 1, the output will be in the on state. When the PLC output is on, current will flow and the load device will be energized. If the PLC memory for the assigned output is set to 0, the output will be in the off state. When a PLC output is off, current is interrupted, and the load device will be de-energized. Specifications of the device you connect the loads to can be critical. PLC outputs are available in different types. Attributes include operating voltage, sinking or sourcing, which is the direction of current, and how many outputs. To appreciate the different type of discrete outputs available, let's consider some of the different output modules available for Allen Bradley 1756 series. Here we have another table, but this time it shows different output modules that are available. Number of outputs. We can see output modules are available with as few as 8 input channels and as many as 32. And voltage. For DC voltages, we see as low as 5 volts DC for TTL and up to 125 volts DC. For AC voltages, there are output modules that handle 24 volts AC up to 240 volts AC. Once again, considering the range of voltages, remember, electric shock can be deadly. Never assume, just because you are working on PLC control circuits, that you are working on voltages low enough to ignore this risk. For example, see this diagram of an AC output module. It is designed to handle 240 volts AC. The common for the module is wired to L1 on the left. The load devices are connected between the output terminals and L2 on the right. Between L1 and L2 is 240 volts AC. From the table, we can see some DC output modules categorized as sink or source. 2 sinking here, one with 16 outputs, one with 32 outputs, and 4 sourcing here, one with 8 outputs, one 8 output isolated, one with 32 outputs, and one 8 output for 48 volts DC. To connect the DC outputs correctly, let's learn about sinking and sourcing outputs. Similar to what we learned about the inputs, it's all about the direction of current flow. Remember, conventional current flow is from positive to negative. Positive potential is considered the source, and negative potential is considered the sink. Consider the diagram labeled Field Wiring for DC Sourcing Output Module. The output module common terminal is connected to the power supply positive. The load devices are connected between the output terminals and the power supply negative. In this configuration, The output module is the electrical source. The red arrows indicate the conventional direction of current flow from the source at the output terminal through the load to the negative rail. Next, consider the diagram labeled Field Wiring for DC Syncing Output Module. The output module common terminal is connected to the power supply negative. The load devices are connected between the power supply positive and the output terminal. In this configuration, the load devices are the electrical source. That makes the output module the sink. The red arrows indicate the conventional direction of current flow from the source at the load through the sink at the terminal of the output. Back to the table of output modules. Let's find the isolated output modules. Here we see 6 modules that are isolated. One rated for 120 to 240 volts AC, 2 for DC 12 to 24 volts, 1 for 125 volts DC, and 2 contact modules rated for DC 5 to 125 and or AC 10 to 240 volts. So let's talk about these isolated outputs and isolated outputs with relay contact. An isolated output module can be connected to devices from different power supplies. In the diagram here, you will see no common terminal. Each output channel has 2 terminals to wire up for each output circuit. Some isolated output modules are suitable for connection as syncing and sourcing. In the diagram labeled Isolated Output Module, Output 0 and Output 1 are wired as sourcing outputs, with the load wired between the output terminal and the power supply negative. Output 2 is wired as syncing, with the load connected between the power supply positive and the output terminal. Contact outputs use relays internally to provide a relay contact, or you may know the term dry contact type of output. Contact outputs can be used in similar fashion to an actual relay contact. Provided the contacts are rated for it, different power sources can be connected, AC or DC. For the example in the diagram, the contacts are isolated from each other, so you could connect different power sources to each individual contact.